All right, time for some review of our parallel lines chapter, chapter 3. Our first learning target is that we can identify angle pairs made by two lines and a transversal. So when we have two lines like this right here, and we have another line that goes through them, this is called our transversal. And it makes two groups of four angles. And those angles can be paired up in different ways. So let's look at some angle pairs. A little side note, there are a couple changes here. If you have an older version of this review, those will be different. But we had to change them, otherwise they don't make sense. All right, let's get into it. So we want some corresponding angles. So which ones correspond to angle 5? Corresponding means in the same position. So angle 5 is in the top left of this angle in this group. So this angle right here corresponds with this angle right here, and that is angle 1. They're in the same position. Same position meaning they're both in the top left. So angle 5 and angle 1. Now angle 1, again we changed that if you have the old one, is an alternate exterior angle to which angle? Angle 1 is alternate exterior. Well, remember, if you could think of this like a house. These guys are interior, like the interior designer. These guys are exterior. Okay, so we want alternate exterior with angle 1. Again, there's angle 1 right there. So which one's on the alternate side, the opposite side of this transversal? That would be 7. So we're picking one from this group and one from this group. 7 is exterior, but it's on the opposite side of the transversal. So 1 and 7 are the alternate exterior angles. So angle 1 and angle 7. Now alternate interior angles, a little different here. So angle 3 is an alternate interior angle. Well, interior is inside that. So there's angle 3. And on the other side would be angle 5. Again, we're picking one from each group. So not 3 and 2, those are in the same group. But 3 and 5, those are angles that are both interior, but they're on opposite sides of that transversal. So 3 and angle 5. So angle 8 is the same side interior angle. Angle 8 is the same side interior, so 8 is over here. And looking in the other group of 4, 3 is an interior angle. 2 is also an interior angle. But 3 is the one that's on the same side of the transversal. So 3 and 8 are are same side interior angles, or the book calls them consecutive. But most people call them same side. So be ready to recognize those pairs. All right, then we also talked about parallel lines, perpendicular lines, skew lines, all right, and also parallel planes. So QP here we have a drawing, and QP is the line that goes through there, right? Okay, so we want to find some parallel lines. All of the parallel lines, well, how about NO? No. So there's a parallel line to that. Okay, so PQ is parallel to NO. All right, we can go ahead and write that out. Why not? All right, so those are parallel lines. So NO is parallel. Now, which ones are skew to QP? All right, well, skew means they don't intersect, but they're on different planes. They're not parallel. Okay, so that blue one is skewed to MO. Didn't trace that very well. So those lines will never cross, but they are not parallel. Okay, so MO is one of them. What other line there does not MO. Okay. We need another line that will never cross. I think there's one more. It never intersects that one. How about MR? MR is never going to touch the blue one, even though it looks like it might touch it here. But using this drawing, we can see that MR is on a different plane. It's back, and it's going to kind of go behind the blue line there. So MR is another option. Those are skew. And those are our other two. Those are the, oh, I'm sorry. There are not. No, there's another one. You see another one? We said MO. And what about this one right here? That's not quite parallel. It's kind of tweaked at an angle. So MN is a skew line also. So all three of these are skew to PQ. All right, so you need all three of them. Next, we have some lines that are parallel. A little reminder, these arrows right here mean that these two lines are parallel. And so we have our theorems for our special angles. We know these two next door neighbors here are linear pair. So that's one of our angle theorems there. And so they add to 180. And so if we take 180 minus 35, we get 145. So angle X is 145 degrees. And the reason for that is the linear pair theorem. All right. Linear pair theorem says that linear pairs are supplementary. And so we just used that. Okay, so the theorem is the reason. Now we have some angles here, angle pairs, about 35 and this y. Those are corresponding angles. Corresponding angles we know are congruent. So we can abbreviate that corresponding angle theorem. You need to know what that is, what CA means. Okay, they're corresponding angles. So that means in the same position. And if the lines are parallel, corresponding angle theorem says that they're congruent. On to the next group here. So we have some angle pairs. We need to match these up. So how about these guys? So those are corresponding. Okay, notice these lines are parallel. That's important. So since those lines are parallel, then 4x has to be equal to 3x plus 23. By the way, this drawing is not drawn to scale. Those kind of look like they might be 90, but that doesn't necessarily mean that they are. So if we subtract 3x, then we have x equals 23. Okay, so we just used the corresponding angle theorem. Okay. And so that's the relationship there. And again, well, nothing, not too interesting. These are linear pairs again. There's no relationship going on here, so we have to use linear pairs. So the connection is this y plus the 4x are supplementary there. They add up to 180 because they are a linear pair. Well, what is 4x? Well, x is 23, so 4x, let's just check that out. 4x, 4 times 23 is going to be 80, 92. So this is y plus 92 equals 180. Subtract 92 from both sides, and we're going to get 88. So y is 88, and we use the linear pair theorem there. So remember, we can use any of those theorems, corresponding angles, alternate interior angle theorems. We know alternate interiors are congruent, alternate exterior congruent, same side interior, so on and so forth. We need to be ready to use those guys. Okay. also be ready to use vertical angles. That's a theorem that will show up as well, which vertical angles we know are congruent. On to the next learning target here. Now we want to create proofs and use theorems about parallel and perpendicular lines. All right, so here we're going to say which ones make the lines parallel. All right, and do some proofs here. All right, so little note: if we're going to make or we want to prove that lines are parallel, we're going to use the converse theorems that we talked about. So the original theorem that we had said that if two lines are parallel, then these angles must be congruent. These are alternate exterior angles. Well, here we want to find the value of x that makes m parallel to n. So the theorem we're going to use here is not the alternate exterior angle theorem, it is the converse. The converse says if the angles are congruent, the alternate exterior angles, then the lines are parallel. Okay, so we're going to make the lines parallel. Little twist there. So we're going to make the lines parallel, so we need to use the converse. And so again, if these two things are equal, 5x, if that equals 2x plus 78, then we'd have parallel lines. We want to make them parallel. That's the idea. So little twist again. And so we can solve this up. This is now all algebra. 3x equals 78. Divide both sides, we get x is 26. All right. So if x was 26, then those angles would be congruent. Then the lines would be parallel. That's the alternate exterior angle converse. We want to make these lines parallel. Well, if we want to make these lines parallel, then these two angles in here need to be supplementary. These are same side interior angles. So again, we're going to use a converse, the same side interior angle converse theorem. So the same side interior angle converse says these two angles would have to be supplementary. So they have to add to 180. Okay, so our equations that we're going to be using most of the time will either be two angles are equal or two angles add to 180. So in this case, they're going to add to 180. So we have our two angles adding to 180. Set up our equation, and it's time for some algebra. Combine like terms. Don't go trying to subtract x from both sides or subtract 2x. Just combine like terms. X plus 2x is 3x. Combine those like terms. And 40 and 35 is 75. Okay. Now we can start moving things around. Sometimes it's tempting to jump too quickly to this. 75. So 3x equals 105, and divide to finish it off. And we get 35. So x is 35. All right, there you have it. Cruising along. So now we want to determine if these are parallel, and if so, we want to give a reason for it. All right. So here we've got two lines and a transversal, and these angles are corresponding angles. So, and remember these marks here mean that those two angles are congruent. So we can say that m is parallel to n. We know that has to be true, and that's by the corresponding angle converse theorem. The corresponding angle converse theorem says if these angles, these corresponding angles are congruent, then these two lines would have to be parallel. All right. Number 11. Here we've got two congruent angles, but notice they're both right around this vertex. We don't have any angle on the other vertex, So we don't have corresponding angles or alternate interior angles or anything like that. And so we don't know that M is parallel to N. We just have to say not enough info. Not enough information to say that any lines are parallel. They sure look like that. They are, but we cannot be sure because we haven't been given the angles from the other vertex. Here we do have some angles. We got an angle up on this vertex, and then we've got an angle down on this vertex. Now notice those two angles have nothing to do with S. So we can kind of ignore S away, and we can see that the lines that it does have something to do with is P and Q. So we can say P has to be parallel to Q because those angles are corresponding angles. They're in the same spot. This angle is in the, well, there's four angles right here. 1, 2, 3, 4. Four angles around this vertex. This one is in the top, the way that it's positioned. This angle and this group of four around the vertex is in the top. And so they're both 90, so they're both congruent. So we have our corresponding angle converse theorem, which says that lines P and Q have to be parallel. Now, be careful. R and S look like they're parallel, but we don't know that. We don't have enough information there. So we have to leave it at P and Q. That's all we know. Okay, here's one we did in class, so you might recognize this. But we've got a couple different things going on. We've got there's an angle right there that's 70 degrees. And there's an angle that's 70 degrees. Well, what kind of angle pair are those? Well, they're inside these two lines right here, and they're on alternate sides of this transversal. So they're alternate interior angles for lines M and N. So M has to be parallel to N, and our reason here is alternate interior angle converse. So the alternate interior angle converse theorem tells us that those two lines are parallel. All right. Well, do we see any other connections? We see two other lines that we would like to say are parallel. It looks like Q and P. Those guys look parallel. Well, let's look at these angles. So 110 is this angle right there, and 70 here is that angle, and those two angles deal with Q and P. Notice they have nothing to do with line N. Line N is not made by either of those angles. So these are the interior angles. They're the same side interior angles for P and Q. So, and they are supplementary. 90 or 70 plus 110 is 180. That's great. So P has to be parallel to Q. And our reason here is same side interior angle converse. So we have to have both of those, both pairs we know are parallel. All right, we have enough information, different reasons, but we have enough information there. So there we're making lines parallel. Let's go on and try a proof here. So we worked on some proofs to prove some angles congruent and to prove lines parallel. So here we want to prove that 6 and 3 are congruent. We know that A is parallel to B and L is parallel to M. Okay, so we need to work our way around here. We got to get from 6 to 3. Now, there's a handful of angles labeled, somewhat random. We'll try to stick to that. If you really needed to, I guess you could make an angle 8 and just throw a number in there. That would work. Let's always start with our given. So our first statement is A is parallel to B and L is parallel to M. You can go ahead and put those on the same one, or if you want, you could do 2 different lines. But those are given to us. So we've got them in our proof now, so we can use them. And we can use all the theorems that we know: corresponding angles, alternate interior angles, same side interior angles, alternate exterior angles, things like that. Well, I want to make my way from 6 to 3, so maybe we could go from 6 to 1. So if we look at these lines right here, focus on line A and line B and this transversal right there. So 6 and 1 are alternate exterior angles for those angles. And we know that alternate exterior angles are congruent. So we can say that angle 1 and angle 6 are congruent. So 6 is congruent to angle 1. And so those are alternate exterior angle theorem. That's our reason, because we know alternate exterior angles are congruent. Okay? So that gave us a connection from 6 to 1. We're trying to get from 6 to 3. We could go lots of ways. We could go from 1 to 4 using alternate interior angles, and then go 4 to 3 with vertical angles. That'd be cool. We could go from 1 to 3 directly now. Might as well go direct. So angle 1 is congruent to angle 3, and that is corresponding angles. So see those guys? 1 is right here, and 3 is right there. So now we're using lines L and M. So we used A and B a minute ago. Now we're going to use L and M in this transversal. All right? So we know that angle 1 is congruent to angle 3. And the reason for that, that's corresponding angles. Again, using different parallel lines, but they're corresponding angles. Well, now 6 is congruent to 1, and 1 is congruent to 3. So we can put those together and say, therefore, angle 6 is congruent to angle 3, and that's what we were going for, right? We wanted to say this angle 6 is congruent to angle 3. And our reason for that, well, we tied these together with the transitive property. 6 is 1 and 1 is 3. So that's the transitive property. Now, there's more than one way to go about that. So we could say that 6 is congruent to 5. Let's see, let's go like this. 6 is congruent to 5. Those are vertical angles. Then we could say 5 is congruent to 7 by corresponding angles. And then we could say 7 is congruent to 3. And we could tie those together with transitive property. 6 is congruent to 5, 5 is congruent to 7, 7 is congruent to 3, so 6 is congruent to 3. We could go that route as well. We could bounce around all different kinds of ways. 6 is 5, vertical, corresponding angles. You could go alternate interior angles, and then another vertical. Different ways to go. So, and then one's not necessarily better. They might be quicker or fewer lines, but it doesn't necessarily mean it's better. All right, the last learning target here. We want to create linear equations to determine if two lines are parallel or perpendicular using their slopes. Okay, we can write equations of the parallel and perpendicular lines. That was our goal in 3C. So we learned two special things. The first thing we learned is that parallel lines on the coordinate plane have the same slope. Slope is just the steepness, and so parallel lines have the same slope. On the other hand, perpendicular lines have opposite reciprocal slopes. So opposite reciprocal slopes, remember opposite reciprocal means their signs are opposite. One's going to be positive, one's going to be negative, and their slopes are reciprocals, meaning like 3/2 and 2/3, 3/2 or 2/3. Those are reciprocals. All right, so that's the key. So first we want to find out if these two lines are parallel, perpendicular, or neither. Well, we don't know until we put in the slope-intercept form. So we need to change each equation to put in the slope-intercept form to find the slope. And all that means to put in the slope-intercept form is we need to solve for y. All right, so our first step is to subtract 2x. 3y equals, and we got 9 minus 2x, which from algebra we know is the same as negative 9x, negative 2x, sorry, plus 9. And then our last step here is we want to solve it for y, because we're trying to put it in the slope-intercept form. Slope-intercept form means we have y equals mx plus b. Remember, we got to divide both of these by 3. Don't just divide one of them. Divide the 2 by 3 and divide the 9 by 3. 9 divided by 3 is 3. So there we have that equation. So our slope is negative 2/3. Right? M equals 2/3. Next equation, I know it's kind of tight here, but we need to solve it for y. So let's get that x out of there. So let's subtract the 6x. And when we subtract that 6x, we squeeze it in here. We're going to get 12 minus 6x, or on the left, negative 4y, negative 6x plus 12. We're going to want that x first, so we might as well put it first right now. And then if we divide everything by negative 4, because we're trying to solve for y, divide everything by negative 4, then we get the equation y equals negative 6 over negative 4, which those negatives will cancel, so that's going to be 6/4 x, and then we have 12 divided by negative 4, and 12 divided by negative 4 is negative 3. So divide both ways. These both get divided, and 6 divided by 4 is just 6/4. So those fractions make that easy. And so our slope here is 6/4, or if we simplify that, 3/2. So we take a look. Are they the same slope? No. Ooh, I messed something up. You see this guy? Is our slope really 2/3? Nope, it's negative 2/3. That's going to change things. Throw a negative in there. So now these are opposite reciprocals. Reciprocals means we have 2/3 flipped over becomes 3/2. One's positive, one's negative. So these are opposite reciprocals. So opposite reciprocals make perpendicular lines. Okay, so these guys are perpendicular lines because they're opposite reciprocals. Perpendicular lines. And we verified and we proved that with our work. Okay. Now we're going to write an equation for a line that passes through the point here that is parallel. So we want it to be parallel. So we look at our line and we notice, hey, this has a slope of 1/3. So our parallel line is going to have a slope of 1/3. Okay? And so we know our slope is 1/3. We know our points, a point that is. So we're going to use our point slope form first. Our point slope form is y minus y1 equals m times x minus x1. We want to have that memorized. Okay. And so that means we take y, which is a variable, minus y1. Well, this is going to be our x1, y1. So we're going to have y minus negative 2, and when you subtract the negative, it becomes adding. The slope is 1/3. And our x1 is the x-coordinate that we know, and that's 6. Now the directions ask for us to convert it into slope-intercept form. All that means is solve it for y and simplify it. So to do that, we just need to distribute this here. So we have y plus 2 equals 1/3 x, and 1/3 times -6 is -2. And we've got to solve it for y. So let's get the 2 off the left side. And that's going to be a -4, right? So we end up with y equals 1/3 x minus 4. So we can start in point slope form, and if we need to, we can change it in slope intercept form pretty easily. All right, good with that. Our last question here is probably the most challenging one. We want to find the distance between a line and a point. Okay, and we've got kind of some steps for you to help a little bit. So we've got this line. I'll draw a picture down here. We've got this line, y equals 1/3 x plus 1. So that's something like this. Well, let's try that again. Something like that. I kind of missed. We'll pretend that we hit y-intercept of 1, slope of 1/3. And then we got this point, 2, 5, somewhere up here. And remember, the distance is found on the perpendicular. So we need to find the perpendicular line. And then we're going to need to measure this distance right here. Question mark. That's what we need. Okay? Well, first thing we've got to do is we've got to figure out what is this point where they cross. And that's going to be using a system there. So we need to first find the equation of the perpendicular line. And so we know that our perpendicular slope is going to be a negative reciprocal. This slope is 1/3. So our perpendicular slope is going to be -3/1. So we can write an equation now. We have y minus y1. Our y1 here is this 5. And our x1 is 2. So -3 is our slope times x minus x1. Point slope form. We're using this point slope form up here, right here. Same thing from up there. But now we have a slope of -3 and a different point. And so now we have an equation. That is the equation of the perpendicular line. So we have this line. That is this blue line right here. We have the red line is what's given to us. We want to find out where they cross. Well, to find the point where they cross, the point of intersection, we've got to solve the system. So we're going to take what we have here. We know that y is equal to 1/3 x plus 1, and we're going to put in for y right there. Again, not a lot of room going on here, but we'll do the best we can here. So putting in 1/3 x plus 1 for y, we get 1/3 x plus 1. And we have -5. That's the left side over here. Right here, y minus 5. We just put this in place of y. And that equals our -3x minus 2. We should say -3 times x minus 2. Now let's just solve for x there in our little tiny spot here. So we have 1/3 x, 1 minus 5, that would be -4. And let's distribute this -3x plus 6. Now we got this 1/3 to deal with. We could go ahead and keep it in fractions, but it'll make life a whole lot easier if we just multiply both sides by 3. Just to kind of keep things in integers. And so we get, multiplying everything by 3. That gives us 3 times 1/3, that is, which is 1x. And 3 times -4, that's minus 12. Distribute 3 here, we get -9x. And 3 times 6 is 18. All right, that should be fairly easy to solve. Let's get all the x's onto one side. Let's add 9x. And then let's get these constants out of here while we're at it. Add 12. And so we end up with 10x equals 30. These canceled, those canceled. And so x is 3. Well, that's nice. So x is 3. We've got to find y. So let's plug this into here. Plug this 3 into that x. Figure out what y is. So y equals 1/3 times 3 plus 1. 1/3 of 3 is 1, so this is 2. So these intersect at the point 3, 2. We found the x-coordinate of 3 and the y-coordinate of 2. That is where they cross. That doesn't have to be a whole number point, but it sure was nice that it is. So what's going on? We have these two are intersecting at 3, 2. And the point we started with was 2, 5. So last thing, part C here, we want to use those. We want to find the distance between those 2 points. If you graphed them out, you could use the Pythagorean theorem. But better yet, it'd be good to use the distance formula, which hopefully we have worked with, and we're starting to get that down. The distance formula just comes from the Pythagorean theorem. The Pythagorean theorem says we have the legs squared. That's going to be x2 minus x1 and y2 minus y1. And then instead of squaring d, we're going to square root this side. So there's the distance formula. So again, we've got our points. The points are 2, 5 and 3, 2. I'll write that down here. So we want to find the distance between those there. So we have, subtract the x's, 3 minus 2 squared. Subtract the y's, we had 3 minus 2, now we got 2 minus 5. Okay, and so that gives us 1 squared plus -3 squared, which is 1 plus 9, which is the square root of 10. And the square root of 10 would be the exact answer. If we wanted a decimal, we can go to our calculator and get that. And that is approximately 3.16. Okay. Square root of 10 is a great answer, but that decimal is okay. Actually, on the test, we'll probably not use calculators, so square root of 10 is what we have to leave it as. Well, there you have it. So we can prove things. We've got our angle pairs we talked about, and ways to make lines parallel. And we've got all these equations. All right, so that's what we need to get mastered and get down for our Unit 3 test. So keep working hard. You're going to do great.